So we're here to talk about Angular2 data flow. My name's Rob Wormland. You can follow me on Twitter at Rob Wormland. I am the newest member of the Angular2 team. I'm an independent contractor, and I live in San Diego, so obviously the weather here is a little strange for me. We're going to talk about reactive programming with event streams. And just to be clear, not React. You are at the right talk, right? And so this is in the context of observables. And observables are a new thing in JavaScript. Well, I suppose they're not new, but they're new to Angular, and they might be new to you, so we'll go through them a little bit first. And just to be clear, in case you read the sort of the news yesterday, we're not talking about object.observe, which was just pulled from JavaScript. So let's talk about what is an observable and why do we care, and why does Angular2 care about them. So they're a little bit like a promise. If you've done any JavaScript at all, probably at this point, you've done promises. They're new in ES6, but Angular's used them for a long time. You probably use them in your JavaScript. But they work with many values, and that's kind of like the first most important thing to realize here. So keep in mind, it's like a promise of many values. And so if you've used a promise, it looks something like this. You have an HTTP request, and it's got a then sort of a callback method, and so you've got a success and an error, and if the request succeeds, you call success, and if it fails, it calls error. Pretty simple stuff, right? So what if you have something that happens more than once, right? So you're listening to a WebSocket, let's say. Promises aren't going to work for that, right? Because a promise is only going to resolve once. So this is the beginning of an observable. An observable, instead of having a then method, calls subscribe. And each time you get a message down the socket, subscribe is going to be called. And then, like a promise, they have an error callback. So you get a success or an error, and if something goes wrong, it'll call the error callback. And of course, because this is something that's going to run for a long time, you need to know when it's done. So an observable has 3 total callbacks. You've got a success, an error, and a completed. And we just call that next, error, and complete. So step 1, right, a lot like a promise, not that scary, pretty similar stuff, not too hard to work with. But they're also like an array, right, but asynchronous. So if you think about this socket message, right, it's sending messages down the stream. And if you think about it, that's a little bit like an array, right? It's an array that arrives piece by piece by piece by piece. And so it's got this sort of similar kind of conditional behavior as an array does. So it works like a promise, but it also works like an array. And that's kind of the best way to describe what an observable is about. It's like an asynchronous array, and it arrives over time. Except that, like an array, and unlike a promise, we can do combinator things. We can do all those things that you're used to doing with an array. So if I have a socket and it's broadcasting messages that have an object, like we saw there, right, with a body property, and we only care about the body, we can just map it. So each time each time a message comes down the socket, we're going to map that one message, just pluck out the body and send that on the stream. So again, it's working like a promise in that it's asynchronous. It's working like an array. And again, we've got these array methods that we can use. We call them combinators is kind of the term we use for this. And not just map, but we've got filter, right? So if we only care about messages that are saying thank you, we can map over them, grab the body, and then filter out and only pass down the ones that say thank you, right? So we're going to subscribe to that new array of talks. One other interesting thing, and this is kind of the big reason that Angular goes into them, and we'll talk about why Angular uses them here shortly, but something that you can't do with a promise is cancel it, right? So a promise, once it starts, is going to complete or it's going to not complete, right? It's going to complete or it's going to error. But you can't cancel it, right? It goes out, and you're either going to have to wait for it to resolve or reject. And there's some discussions right now. If you go on GitHub and you read like the fetch repo, you'll see that they're talking about, okay, so how do we cancel a fetch request? And fetch is this new API in ECMAScript, and it's in Chrome. I think it's in Firefox. And it's really useful, but in fact, it's a little bit less useful than XHR, the kind of hard way of doing it, right? Because there's no way to cancel it. And we have this kind of philosophical problem that if you have a fetch request that gives you a promise and you want to cancel it, what do you call cancellation, right? Is cancellation success, or is cancellation an error, or is it some sort of third condition that we're not really sure about? And if you say it's a third condition, then that kind of breaks everything that we know about promises, right? So we have this kind of problem that you can't really describe cancellation properly with a promise. Observables, though, have this kind of behavior built in. So when we subscribe, instead of calling then, we're going to call subscribe. What we get back is actually called a subscriber. And so that let talk subscriber there on the left represents the sort of act of subscribing to this stream of messages coming in. And obviously, because this is a WebSocket, it's going to run forever, right? It's just going to keep piping values down the stream for us. And at some point, we'll want to stop listening. We'll want to cancel that. And so built into that talk subscriber, we have an unsubscribe method. So at any point, we can just say unsubscribe. It will close down the WebSocket. And the neat thing is, the way that you set up an observable, it means that it will, for example, close the WebSocket. Or if you're listening to DOM events with an observable, it will sort of unregister the event listener, right? It's really good at cleaning up after itself. And this is built into how observables work. This is kind of a core idea inside of observables. So again, it's like a promise, like an array, but it's cancelable. And those are kind of the three primary things that you need to understand about an observable to understand kind of why they exist. So they are on the ES 2016 standards track. If you check out that GitHub repo, you can watch the discussions as this evolves. And like Angular used Q back in the day, we used Q in Angular 1 kind of long before promises became part of the ES 2015 spec. We're using a polyfill called the Reactive Extensions project. And this is not new. RxJS is the sort of JavaScript version of this, but this exists in many languages. There's one for Java, there's one for C#. There's a ton of these, and it's actually a Microsoft project. So this is a Google library using a Microsoft project in kind of the core. So RxJS polyfills observable for us, and it's been around for a long time. We're using the newest version called RxNext, or RX5 at this point, and that's a sort of a total rewrite of reactive extensions for JavaScript designed to match this spec that's being developed. So this is kind of the new version of a very old project, a long-running project, and we use it in the Angular2 core at the moment. And so this is all nice and theoretical, right? But I think probably the best way to sort of describe this and see how this is useful in an application is to just show you, right? So we're going to step through, we built a little Angular investment manager when we were demoing this for Angular. So, and wow, that's really low resolution. But this is a Typeahead, right? And if you've done sort of any web development at all, you've probably built a Typeahead at some point. And so Typeahead kind of, Angular makes it pretty easy to do. Angular 1, they're not too hard to do, but there's actually a lot going on in any Typeahead, right? And so we'll look at kind of how we do it in Angular 1 today or Angular 2 today in sort of a classical style, and classical for a library that's not yet released. I realize this is a little funny, but we'll do that. So this is what it would look like in Angular 2 today. So we have on the left there what the template looks like, and there's that sort of strange-looking ng model, but that's, if you've used Angular 1 today, that's kind of the equivalent in Angular 2. So all we're doing is we're taking that ng model, we're assigning it to an input, and we're assigning an event handler there on keyup. And so the way to read this is that we've got this ng model that's grabbing the value, and then each time we type in the input box and we let go of the key, it's going to fire that search changed event. And so it's going to fire the search changed method there. It's going to do the search, right? We're using fetch in this case to make a fetch request. When that fetch request comes back, then we're going to map it. We're going to actually then get the JSON out, and then we're going to assign the tickers, that's that list of results that are coming back, to the controller, and then simply iterate over them. But it's not that simple, right? Like on a Typeahead, the first thing you want to do is make sure that you are not firing a request every time somebody lets go of a key. You want to debounce it, or throttle is kind of the term we use for this. And so in a sort of classical style, you have to keep track of stuff here, right? So we're using a timeout value. So every time you hit the key, it starts a timeout, and if you type another key, it's going to cancel the previous timeout. Before piping that value, you have to actually do what we want it to do. And the other thing you've got to keep track of that's kind of interesting is making sure that responses come back in order, right? So if you fire a request, and then you fire another request right after it, if your server hiccups, if it slows down on that first request, responses could come back out of order, right? And you don't want that happening. So you kind of have to keep track of the latest request, right? So there's these kind of two things that you're tracking alongside what you're actually trying to do, which is just make a request and get some values back. And so pitfalls to that, right? We have to keep track of all this stuff. So we've got this search timeout. We have to keep this property in our controller. It's just an extra property we have to keep track of. We also have to keep track of that current request, right? So we've got these two variables that we're tracking that are kind of out of band. They're not really about what we're doing, but we have to keep track of them to make this thing work. And obviously, libraries like Lodash and things have Debounce built in, but it's not something that it's not really part of the core of what we're trying to do. Is you have to bring in third-party libraries, or you have to sort of just think a lot more about what you're doing. And the other thing, of course, is that it's inefficient, right? So if we make this request and we keep track of this current request, if we make 2 more requests, we don't care about the results of those previous 2 requests, right? We really just don't care about them. So we sort of ignore them. They're not going to stop there. They're going to keep running. They're going to keep using bytes. And on mobile and things like that, obviously, we're wasting a lot of bandwidth just firing off requests that we don't care about. So again, observables are cancelable, right? So this is that thing that we talked about just a few minutes ago, that this is where observables actually might do a better job of this. So let's look at how we do the Typeahead in Angular2 now with streams, right? And streams is this kind of, you'll probably hear me switch between streams and observables a couple of times more here. And streams are just a kind of a friendly way of saying observables. And so in Angular2, we use observables in a lot of places. And the first one of those is forms. So Angular2 forms, we have some new hooks. And to be clear, if you use Angular1 today and you really like ngModel and you like how it works, you can keep doing that. You don't have to change to this newfangled way of doing things, but this gives you some more options. So you'll notice instead of doing an ngModel, what we've done is we've created an abstract control here. And this control is just something you can import from the Angular core. We're going to assign it to our controller and just give a variable. And then in the template, we're just going to say this form control is called search text, so we're linking those 2 things up. And that's it, right? Like, we don't have an ngModel here. We don't have an actual model on the form, because all we really care about is the value coming out of it, right? We don't care about having an object to keep track of this. And so in Angular2, that search text control returns an observable. So this valueChanges that you see here is an observable. And what it means is that every time you type in the box, this valueChanges is going to fire. So if I type H, it's going to give me an H and that subscribe function. If I type HE, it's going to spit it out, right? Very simple. So it looks like this. We'll zoom in a little bit. So we've got this search text control. We're subscribed to the valueChanges of it. And so the first thing we want to deal with on a Typeahead, right, is throttling. We want to debounce those values. And nice, RxJS has it built in. So we have a very simple operator. This is another one of those combinators like map or filter or reduce. And this is debounce time. So all this says is each time the value changes, right, wait 200 milliseconds before passing it down. If a new value comes in, send that one instead. So that takes like our 6 lines of set timeout and clear timeout and keep track of that value, and it takes it down to 1 built-in combinator, which is really nice. So part 2 of this, right, we've got these values coming off of our input box, and we want to then turn those into requests, right? We want to make a request to the server for each one of those values that come down the stream. And so this is kind of the big controversial thing, right? That Angular2's HTTP library, unlike Angular1's HTTP library, we use observables in this. So instead of returning a promise from Angular2 HTTP, we're going to return to you an observable. And again, to be clear, if you want to use promises, if this is something that you go, nah, I don't want to do this, then that's fine. You can take an observable and you can very easily cast it to a promise. But what you can't do is take a promise and turn it into an observable. So we're sort of starting with the more kind of generic primitive, the observable, and if you really want to, then you can just say toPromise. But for the sake of this, we're going to stick with observables. So all we've got here is a little kind of basic Angular2 service. That's a searcher class, and it's got a method on it that's get, and that takes the value. So that's just going to take our search symbol, basically. We're going to return an HTTP request, so we're doing http.get there, as you can see. And all we're going to do is stick that value on the end of a URL. And then, interestingly, what we're doing is actually mapping the response that comes back, and we're calling this res.json. So Angular2's HTTP library works a lot like fetch. We actually kind of designed response and request to kind of match the fetch API. So it's quite a similar kind of API that you're used to. So again, the way to read this is HTTP GET and then map instead of then the response and only return the JSON, right? So when we wire that in, it looks like this. So we've got our value changes, and each time the value changes, we're going to wait 200 milliseconds. And then we're going to map that text that's coming out of the value change into a request, right? So if you've done this with promises, this is kind of a similar thing. If you've ever done promise.all and you take an array of values and you do map, right, and you turn them into promises. And so the way this stands right now, if you fired this off, what you'd actually get in the subscribe method is basically an observable, and that's not super useful to you there, right? So you have that the same kind of problem here that you have with promises, that if you map them, you need some sort of way to unwrap them, right? You need to wait for the promise or the observable to complete before that value comes down. And luckily, RX has this built in, and they call it FlatMap. And so FlatMap is one of these things that when I learned about it, it takes a while to kind of figure out what it's doing, but when it clicks, it's like an incredibly powerful core primitive to how all this works. So what FlatMap does in this case is it will take the text that's coming in from the previous step, we will turn that into an HTTP request and then a response, obviously, and so that searcher.get returns an observable. And what FlatMap will do is it will wait for the observable to spit the next value on down the stream and actually pass the response to our subscribe method. So basically it's called FlatMap because it flattens out that kind of asynchronous bump in the stream, if you like. Now, FlatMap, very useful here, right? But again, this is where we want to make sure that we're not using requests that we don't care about anymore, right? We want to, at some point in the stream, cancel the things we don't care about anymore. And so again, RX has a SwitchMap operator. So this works, again, almost exactly like FlatMap, except that if a new value comes down the stream before the previous one has completed, it's going to cancel that request. And so again, this is one line to do kind of 6 lines of let's check that our latest response is coming in, and one line to do really what we can't do at all with a promise. So just to read that back again, it's value changes. Each time the value changes, wait 200 milliseconds, turn that into a request by mapping over the text and returning into a request and then a response. But if a new value comes down the pipe before the previous one has completed, then cancel the previous request, ignore it, get rid of it, and only passes through the latest value. If you've used RX before, this used to be called FlatMap latest, but now it's called SwitchMap. So again, value changes, debounce, SwitchMap, subscribe. So what we'll get in that subscribe method is the latest value that we care about, right? So in a classical style, we'd basically take this, we'd subscribe to it, we'd get this list of tickers, and then we would take these tickers and we'd assign them to a value on our controller, and then iterate over them. So this is Angular2's sort of ng repeat. If you've used Angular1, this is just a simple iteration, basically. So we're going to say for each tick of the tickers array that we're getting back, take that ticker, just show us the symbol, right? Except that we've got this new tech in Angular2 called pipes. And so pipes are kind of the third link in the stream. So if we talk about we have observables coming off of views, and then we're doing things like transforms and combinators and flat maps and switch maps, pipes are the output of all of this stuff. And so, again, if you've used Angular1, a pipe, you can think of it just like a filter. So this is an Angular1 filter, basically. And so it's today, which is a JavaScript date. And we put that pipe, and then this date filter, and it just turns a JavaScript date into something readable. So it turns in November 4th there. So if we go back to our stream here, our Typeahead, we've got our value changes. We're going to debounce them, switch map them, and then subscribe. But with a pipe, we can get rid of the subscribe, because we're not going to actually subscribe in the controller, and then just assign that to the actual controller itself. So the way to read this is this.tickers is an observable of value change, debounced, and switch mapped into requests. So this.tickers in this case, if you've used Angular1, again, back in the day, the early days of Angular1, you used to be able to assign a promise directly to a controller, and the view would unwrap it. And we took that away, I think, in Angular 2. I'm sorry, in Angular 1.2. And so we've reintroduced it here. So again, we've got this.tickers, which is effectively an observable of responses to our requests. And so this is our original syntax, and we've got this async pipe in Angular2. This is built into the core. And so this async pipe will unwrap this asynchronous observable and then pipe those values into the view. This works for promises as well. So again, if you're not into observables, you can do the same thing with a promise. You can just do like this.tickers is something that returns a promise, and this async pipe will unwrap it. So kind of simple metric here, right? This is 26 lines of code to accomplish what we wanted to accomplish here. So we're doing all this kind of set timeout, clear timeout, blah, 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 blah. Whereas with the Typeahead and the reactive style, we've got, again, simple this.tickers, valueChanges, debounced, and SwitchMapped, and that's really it, right? It's pretty simple. So I've got a little demo here of this app that we built, and I want to show you the Typeahead, which is pretty cool, and then some of the other cool stuff that observables give you. This is a really powerful app. There's no promises at all in this app, and there's a lot going on, so I'm just going to kind of step through it real quick for you. So you can see this is, excuse me, make that full screen. So basically, it's this investment manager. We're actually using WebSockets here to listen to tickers coming off of our server. So you can see we're waiting for a connection here. So we haven't actually done anything. We don't have an open connection to the server. So I'm going to search here and look for a ticker, type in the box. And so these are just a list of sort of, I think they're the New York Stock Exchange ticker values for stocks. So we're going to select one. And you can see what it's done is connected to our server. And it's basically started piping values to the view. So again, I'm going to do this and just search for another thing. And so as I use this Typeahead, as I search for things, it's actually canceling the previous request that's going out and debouncing my request, right? So if I do one, it's going to debounce it. So as I subscribe to these, I get multiple graphs going through. Subscribe to maybe one more. And so I've got these 3 graphs that are streaming values from the server. And what's cool about this is as I unsubscribe, so this close button is unsubscribing to each of those observables of ticker values coming out. And as I close them, when I get to this last one, so I only have one left here, it's going to close the server, close that socket. So because we can keep track of subscriptions and unsubscriptions, it makes it really efficient when we connect to a server, via WebSockets. We can keep track of how many listeners we have, and as we unlisten, when we get back to 0, we can unsubscribe. So I'm just going to do this again and reconnect to a couple of them. And this is kind of my favorite thing about observables here, and I hope this works because this is a live demo and sometimes it doesn't. What I'm actually going to do here is, so I'm connected and I've got 2 kind of tickers streaming through here, right? And what I'm going to do is kill my server. And so you'll see that number 1, my graph has stopped ticking, right? Because I'm not getting any new values coming out, and that's closed there. And you can see that my socket is actually retrying. And so it'll wait a few seconds, it'll retry, and if it doesn't, you can see it kind of flashing as it tries to reconnect there. So hopefully now, if I fire my server back up and switch back to this. So at this point, right, it's retrying, and when it retries and it actually gets a successful connection, it'll reopen that socket using that observable and actually go ahead and just kind of keep piping everything down the stream as normal. I'm really glad that that worked, actually. So again, just to kind of go over that one last time, we've got a Typeahead. This is all using observables. So again, I'm listening to values coming off the view, making requests with them, turning them into responses, and then piping them into the view here. And then with the actual subscribed graph, this is subscription of observables. This is a D3 graph. It's just being rendered each time a new value comes in. And then as I unsubscribe to these, it'll close the socket for us. So the code for that is really pretty simple. I probably should have opened that up first. Apologies. Cool. So the Typeahead itself is here. So we've got that ng form control we were talking about earlier. We've got our tickers. So we could take an observable from the view, debounce it. In this case, we're actually waiting for distinct values. So I want to make sure that I'm only searching when I have a new value coming down the pipe, switch mapping it, making those requests, and sending it back to the view. The socket service, actually, let me show you the template there. So this is that, again, that ng4 ticker of tickers. I'm using an Rx pipe here. This is kind of a hack at the moment because we've just added this to Angular2. So this Rx pipe is doing the same thing as that async pipe, just piping through these asynchronous value and showing us the symbol and the company name. The WebSocket service is a little bit more complicated. Where is that? Services, WebSocket. This WebSocket service is all observable based. And effectively, we just give it a URL on a WebSocket, and it will open up that connection. It will do subscriptions. It will listen to the on open and queue up messages to send them. When it closes, it'll close the stream for us. It'll complete everything. Each time a message comes in, we're going to pipe that new value into the socket. And then we've got this unsubscribe function here. So this is that unsubscribe I was calling on my earlier subscriber. When we call unsubscribe, it'll call socket.close and close everything down for us. Each time a new message is sent into the WebSocket, and then in this case, this is my unsubscribe and resubscribe messages. We're just sending data or queuing up data to be pushed down the WebSocket. And then each time a new value comes in, again, we've got this observable of socket messages, and so they're being pushed into the queue. Yeah. So is there anything else interesting in here? And then so this is the actual Angular service that uses the tickers. So again, we've got this did open, will open. These are all kind of familiar things from WebSockets. We're going to get a ticker. We're going to get an observable returned from that. We're going to listen to the subscription, and we're filtering out only the symbols we care about and subscribing to those. We can send socket messages out to activate a subscription. And again, every observable here has this return function. And this is probably a good place to see promises you've seen before, that you create a new promise by doing new promise and the resolve and the reject. An observable is created sort of manually with this observable.create and then this subscriber function. And this subscribe basically has three properties. So we can say, I'll do a bit of live coding here, subscriber.next passes a new value down the stream, subscriber.error, look at my keyboard while I'm doing this, and then subscriber.complete is how we would close this stream. So again, this is kind of the same sort of syntax as you would use if you were creating a new promise. That's basically how that works. And then every observable, so again, I've done this observable.create, and then from the creation function, from that observable create, this is where you return your unsubscriber function here, so that's what this is. So if you create a new observable, so like a promise, you don't actually return anything from the factory function. With an observable you return this method here, and this will get called when you call unsubscribe, and in this case, this allows us to close our socket. So I'm sending a socket message to say, unsubscribe on the server from that ticker I was listening to, and then actually close the subscription. So I think that was my last slide, actually. Let's just see. Yep, that was my last slide. So just a quick review, right? This is pretty new to us in Angular2 as well, right? One of the things we're sort of experimenting with this quite a bit. We realized that there's a bunch of new shiny stuff here in Angular2. So again, just to be clear, the Angular1 stuff that you're used to, all of that still exists, right? There's still ng model, there's still kind of regular forms that you like and regular form validation. HTTP will still work with promises if you like that. But at the core of things, we've added these observable methods, these observable operators, so that we can kind of do more interesting things and do more efficient things. And we'll kind of experiment with this as we go. We've got a few different sort of things in the pipe here. We're building a data access library. So if you use $resource in Angular1, that was all kind of promise-based. We have a new data access library called Tactical that we're building. Tactical is all observable-based, and it does things like offline sync and offline access and push messaging from WebSockets. We're also working with the folks who are building Falcor, if you've heard of the Falcor project from Netflix. We have some pretty cool little hooks and templating for things like Falcor and Netflix's Relay. The other really interesting thing about this, and I probably should have popped up some slides on this, but if you use things like React and you've used Redux or Flux, things like that, that sort of one-way data flow idea works really well with Angular2. And again, because we can do these things observably, right, we can do things like listen to a Redux store, and each time a new value or a new state change happens in Redux, we can push that to Angular2. The really big deal about all of this, when we talk about performance, Angular2 is a big thing on performance. The interesting thing about observables, because they are pushing values to us, right? What we can do is anything that we know is going to be observable. So in this case, we had this Typeahead, so we were doing requests and responses with it, or my WebSocket, which was pushing values to us. If we can guarantee that a component we're using, so in that case, like my graph or my Typeahead, if I know that I've got an observable giving me the data as opposed to just a static value, we can actually turn off change detection for that component. And it means that if we've got change detection turned off for a component like the graph, everything below the graph, all that change detection gets turned off. So it means that each time we do sort of a check loop, we don't have to check certain things. And if you've got an app that's entirely based on observables, like the little demo was there, we actually don't have to check almost anything. And that obviously makes a huge difference to performance. So this is why we've looked at observables. We know that if we can get values pushed to us, we can do some interesting things. There's a lot more coming on this, and we'll be blogging about this, and I'll be blogging about this in the next few weeks. But this is kind of like the bleeding edge of what we're doing in Angular2. So again, we've got it in forms, we've got it in HTTP. Our change detection is actually observable based now. We've got those pipes in the view. The other thing is if you've used libraries like Bacon or Kefir, I think is the other one, we want to make sure that that sort of observable stuff works with Angular2 as well. So this is not just like an RxJS thing. We're using Rx at the moment, but we want to make it as flexible as possible. So if you're using Angular2 or you're playing with Angular2 and you've got some ideas on how to use this, send me a tweet or send me an email or whatever on GitHub, and we'd be happy to help you out with that. So thanks. That's kind of the end of my presentation, but any questions, give me a shout.